For our last booklet, we are going to consider volume. So this will be the last part of measurement. The nice thing about volume is it is in many ways simpler than surface area. Surface area, we have to add up all these different surfaces, try to figure out what it is. Volume, it tends to be a little more straightforward. Volume is just the amount of space an object occupies. So everything has volume. You have volume, your cell phone has volume, your water bottle has volume. Everything takes up space. So the volume of a solid is, like I said, how much space, the measure of how much space it's occupied, and we measure it in cubic units. So when we had distance, so point A to point B, this is one dimension. That was just in units. So for example, we might have centimeters. Area, we're talking about covering something. If we have surface area, we have a three-dimensional object, but we're still covering that object or making that object. We're talking about the outside of the object. So we're talking 2 dimensions, units squared, for example, centimeters squared. When we have volume, now we're talking about filling up. How much space does this thing take up? So we're talking about filling up the whole thing in a sense, and so we're talking about 3 dimensions. So we have units cubed. So for example, cubic centimeters. So remember distance, just the units, area and surface area. Okay, because surface area, we're still talking about the area that it covers. We're not talking about how much space it takes. It's units squared, and volume, when we're talking about space, now we're talking about cubic units. We have a prism. It's calculated just with this formula, so the area of the base times the height. So in example 1, we have Alfred. He has a bulk container that holds 200 cubic inches of dog biscuits, and he wants to sell the biscuits in smaller boxes that measure 5 by 8 by 6, and we want to know how many boxes he will need to sell the dog biscuits. So he's got 2,000 cubic inches, and he's got these smaller boxes. They're 5 by 8 by 6. So here's our box. Let's say that's 5 inches, 8 inches, 6 inches. It really doesn't matter where we put the dimensions, because if we flip this box on its side, now it would be maybe 8 by 6 by 5. Okay, but just pick spots and make sure that we've got them all covered. So length, width, and height, we have to make sure all 3 dimensions are taken care of. Okay, so volume, well, my base is a rectangle, so it's length times width times the height. And if you look at your formula sheet, you'll see that the volume of a rectangular prism is length times width times height. So that's 5 times 8 times 6, and that's 240 cubic inches. Again, like I said before, if we're writing inches or feet as squared or cubed, please write them as FT or IN, not as with the little lines. Okay, so we've got one box is 240 cubic inches. He has 200,000 cubic inches of dog biscuits. How many boxes do we need? Well, we've got that one box holds 240 cubic inches. How many boxes will hold 2,000 cubic inches? So cross multiply. Now we've got 240 times x is equal to 1 times 2,000. So we need to get x by itself. We're going to divide by 240, divide by 240. 240 divided by 240 is just 1, and 2,000 divided by 240 is 8.3. Now, you could answer this question in a couple of different ways. How many boxes will he need to sell all the dog biscuits? Well, we could say that it'll be 8 boxes and he'll have some dog biscuits left over, but he wants to sell all the dog biscuits. So we're going to say, well, to fit all the dog biscuits, he's going to need 9 boxes, and he probably just won't fill them all to the top. So he will need 9 boxes, boxes to sell all the dog biscuits. Because they're just not going to fit into 8, so he's going to need 1 more.